Hello, this video is about homework 3. So there is an important new element you need to learn from homework 3. So in the single regressor case, reporting the results is not that difficult and was too easy. So I did not care much about how you report the results. But from now on, when you have more than one variables, and the number of regressors could be quite a few, and then clearly reporting the results is important in your writing. So you have to summarize and like you need to help the reader to read and to better understand the results. So the standard is a regression table. So usually regression results are reported in a regression table. And so in this homework, you need to practice how to make a regression table and how to read the table. So we are going to start from the very simple case, but I'll first show you how it can be generalized. So I don't know what the content is. Content is not important. I just want to show you what I see in research articles. So when I read research papers, this is a typical like image format of the results. So in this table, in one table, there are 9 columns, 9 result columns. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 different regression models or estimated, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There are 13 regressors in total, except like other than the constant, other than the intercept. So 13 variables are included in total, but some and below that, in the bottom, you see observations, number of observations, and R squared, how good the fit is, and dummy variables, industry dummy, year dummy. You don't need to understand the last 2 lines, but so this is a typical format I see in like maybe what you need to do in the future, and like when you make a report in your job, or if you go to a graduate school, then your dissertation, your master essay may have a report like this. So I want you to get accustomed to this table, these results. A simpler version, another result from Google. And so model 1, model 2, model 3, there are 1, 2, 3 variables and constant, intercept. And sample size n is 196, R squared is calculated this way. And this is, these two are the most complicated and maybe a little bit easier to see. And what we see from homework 3 is this. This is our regression table. You're going to see from homework 3. So, and let me show you the homework first. The homework is not complete, but so this is question 1 from homework. This is question 1, and simply speaking, we consider how the average hourly earnings is determined. We are interested in how the earnings is determined, and we consider several variables. The data is from 2015 CPS data, and the data include 25 to 34 years old people, men and women, full-time, full-year workers, and the total sample size is, as you can see, more than 7,000. So the candidate variables, candidate regressors are college degree, whether you have a college degree or not, whether you are a female or not, how old you are, and where you live, Northeast, Midwest, South, and intercept. So intercept is kind of the the default. So we are considering these kind of variables, and what this column means. Each column, there is one column, like there are 3 columns, 1, 2, 3, and there are empty cells in each column. So it means that in the first column, in the first one, the activated cells are college, female, intercept. So only 3 results are given in the first column. That means there is one regression model. So first column represents the first regression equation that includes only intercept, college, and female. So those empty variables are not included in this regression. So there is no results for them. So let me come back to PowerPoint, and so then in that way you can understand 3 regressions. So I am comparing 3 different regression estimates. So on Stata, you have 3 different regression commands, and you collect those results and make one table, right? So then, so simply 3 regressions are reported in one table. So the first column can be represented this way. Average hourly earnings is estimated to be this way. Estimated this way. So there is only intercept, college, and female. And the second column activates another cell which corresponds to age. So now you additionally include age in the regression model. So the average hourly earnings is on intercept plus college plus female plus age. So 3 regressors. If you include intercept, 4 regressors are used in the second regression. So there are only 4 estimates are reported. Similarly, the last column includes 1, 2, 3, 4, 5, 6, 7. 7 or intercept plus 6 regressors, 6 variables plus intercept are used in the third regression model. And equation form, you can have this. So there are more variables. I could not write all of them. So like this, as you can see, it collects 3 regression results into one. And then once you understand one column is for one equation, then now you can understand what these are. So standard error of regression is reported for each of the equations. So the standard error of the regression can change if you change the variables. So you have to report separately. And also R squared is different if you change the model. Like if you include more variables, then R squared will increase. And sample size is the different, can be different. In this case, the sample sizes are the same because they use the same data set. But in some cases, sample size may change. For example, when you want to include the regional dummies, these regions, but some survey respondents did not answer these questions, then to include these variables, you have to reduce the sample size by deleting those unanswered observations. So that's an example where the sample size can be different across columns, across regressions. So then, as you can see, the regression result in the table is a very convenient way to summarize and compare different regressions. Like for example, the effect of college. If you're interested in the effect of college on earnings, then you can see it does not change that much by including additional variables. So omitted variable bias is not a big problem in these regressions. And also the effect of the gender difference, like gender difference is somewhere in between them. So when you include age, there is some change, but including region does not change. So gender difference may be associated with age, but not with regions. So these kind of comparison helps you better understand what is going on in the data and the relationship between those variables and what's important and what not, and how much the estimate changes when you add some variables. So anyhow, in the homework, you have to learn how to make the table. So your answer, like, so in the second question, you are going to do data and the results must be reported in this form. So that's what I expect from you. So you need to do that way. And some additional comments. This regression table is not complete at this point. Like for example, standard errors are important but are not reported. Standard errors for like each coefficient is not reported. So it's still an incomplete but simpler version of regression table, and I did not include them because we are going to do that in homework 4. So later you are going to complete the table in later. And also just if you notice this this difference, so you may wonder why the intercept changes this much. Like the first two variables do not have much change by including additional variables, but the intercept, the behavior of the intercept is quite weird. So I will explain. So let's think about the interpretation of this 18.15. So this is from the first regression, we only use college and female. So the intercept must be interpreted as the expected hourly earnings for a man, it means, so remember, again, like back to the beginning. So the intercept is the expected outcome when all the regressors are 0. If all the regressors equal to 0, the expected outcome is the intercept. Then we would like to see what college equals to 0 and female equals to 0 mean. College equals to 0 means without a college degree. And female equals to 0 means a man. So not a female, not college graduate. So in that way, okay, then the point here is age is not included. Age is not included, so there is no restriction on the age. If so, age is not restricted, so you can think it as this intercept is the expected age for a man without a college degree. But age is not included, but then you may think this man is on average years, like say 30 years old. If the 30 years old is on average, so in terms of the average, the man is on the average. So in terms of age, he is at the average. So he's for a representative man without a college degree. This is the expected earnings. But in the second equation, 0.11 is the expected outcome when college equals to 0, female equals to 0, age equals to 0. So that's critical. You have to include this condition, like because you added this variable. So and then obvious. So how much are you going to pay? How much do you expect for a 0-year-old newborn man without college degree earns? So in that sense, it is not absurd. So of course, it has no meaning. You cannot estimate newborn guy's earnings, but just mathematically, this is the interpretation. And that's why, because of this additional condition, there is a big difference. So this is maybe age, I would say this way. Age is, say, average. So age is set at average, but in the second case, age is set at 0. That is a big difference if you think about the data set. The data set includes 25 to 34 years old. So the average must be about 30. So then if you think about 30, then they must be comparable. So like for increase in like if you get 1 year older, then your hourly earnings increase by 0.6. Then 30 years old will increase about $18. So then these two become comparable. 18 is 30 times this. So that's why there is a big drop here. And these two guys are similar. Okay. Okay, so then I think you can do question 1 from homework. Yeah, do your best, and please keep in mind it is a writing intensive course. So the questions, I understand you make mistakes, so I'm very generous. If you don't understand the materials, that's fine. That's why you are taking the course, and I'm willing to help you if you have questions. So let me know if you have questions, but try your best, do your best, and show some respect. Okay, bye. See you later.